New concept time, complex conjugates theorem and the irrational conjugates theorem. These are very much related because of the fact that I is the square root of -1. And so the fact that we're dealing with square roots and I at the same time, not surprising. And you know that if we have a square root or I on the bottom, if we said 3 over 2 plus the square root of 5 or so, we'd want to get that off the bottom. And if you remember, the way we rationalize the denominator is we multiply by its conjugate. If you recall, this is what we do to get rid of the radical on the bottom, or same thing works to get rid of the I on the bottom. Okay, either way I'm getting rid of something on the bottom. So the fact that these are together shouldn't be too shocking. And what we're saying is that if we have A plus BI, in other words, for example, 3 plus 7I, then we also have 3 minus 7I. In other words, let me just write an example here. We also have its conjugate there. Okay, if you have 1 as a root, if one of them is a factor of your polynomial, the other one has to show up too. You can't just have one, you have to have the other one. And the same thing happens here. If you have A plus the square root of B, you also have A minus the square root of B. That's all we're saying here. If you have one, you can assume, you know that you have the other one. So here we go. It says write a polynomial function of least degree. Don't overdo it. Don't overdo it. Do the smallest possible. You could make one bigger, but don't. Why would you do that? That has rational coefficients, a leading coefficient of 1 and 3 and 2 plus the square root of 5. Okay, as zeros. If I have 2 plus the square root of 5, I know that I also have 2 minus the square root of 5. Okay, so you can see how they build this. They say, well, here we go. I'm looking. Oh, leading coefficient of 1. I was thinking that 1 was a root. No, it's a leading coefficient of 1. Okay, fine. Leading coefficient of 1. That means I get to have 1 out in front. That's nice. That's convenient. That's pleasant. But 3 means I'm going to have x minus 3. And there we go. There's one of my factors, x minus 3. And the other factor is going to be x. X minus whatever I come up with here and here. Okay, so it's going to be x minus this and x minus that. And then I guess I keep that together. I was thinking, well, we could distribute the negative sign, but why? Look what we do down here. We say x minus 2 times x minus 2. That's x minus 2 squared. Okay, and then we say, if I say x minus 2 times plus and x minus 2 times minus, they're going to cancel out. As we figure with the conjugate, they're going to undo each other. That's why we multiply by the conjugate if we have that on the bottom, because there's no middle term and it gets rid of the radical or the I. Okay, so no middle term, and then the square root of 5 times the square root of 5, it's going to be negative. Well, if I multiply the square root of 5 times the square root of 5, I get 5, and it's a negative, so I get a negative 5. Okay. And then, let's see, what do? They go ahead and multiply. After we do that, let me get rid of that. Once we do that, then we go ahead and multiply this out. And it's x minus 2 times x minus 2, and we FOIL, or we multiply the binomials together, x minus 2 times x minus 2, and we get this. And then we can combine the 5 and the 4 and make a negative 1, because the negative 5 wins by 1. Okay, and then what we do is we multiply this binomial times this trinomial, and we get this. Okay, we've been practicing. We've been saving up for this problem. We've been practicing the pieces of this problem, and then we simplify and we get our answer. Okay, and we can check our result by plugging in 3, and it gets us 0. Oh my, we can also plug in the other. Oh, well, I don't think we'll do that. But It is true. We could do that. We could do that. It should work for us. Okay, so now let's think about what we have. We have x is equal to 2. Okay, so I know what that looks like. Well, by the way, it's very nice that we have a leading coefficient of 1, that I don't have to think about that. I can say x minus 2. There we go. I have 2. That's great. Okay. And then I have 2i. Oh, I know what that means. I also have negative 2i. Okay, so that's fine. We'll get to that. And then I have 4 minus the square root of 6. Well, I know I also have 4 plus the square root of 6, because that's how this works. Okay, so let me go ahead and write this out. I have x minus 2 times my other factors, which is x minus 2i and x plus 2i. And I also have x minus the square root of 6, and I have x minus 4 plus the square root of 6, because I have to have the conjugates. Okay. All right, so when I do that, what do I get? Well, I guess we could do the first part. First, we'd say x minus 2 times, I know what's going to happen here, no middle term, right? Because they're conjugates. So I'm going to get x squared, and I'm going to get minus 2 times 2 is 4, I times I is I squared, and I squared, if I is equal to the square root of minus 1, then I squared is equal to minus 1. So this negative 4, it's now going to be positive 4. X squared plus 4. And as I like to say, you can't factor the sum of squares unless you start talking about imaginary numbers. Well, sure you can factor it if you use imaginary, but I've been saying you can't do it because we're looking for real answers. And so hopefully that fits into your view of how things go. And then let's see, this last part, we're going to say, let's go ahead and do this. We'll say x times that, and we'll say x times that, and we'll get x squared, and we'll get a minus x times 4 plus square root of x. Do I want to go ahead and distribute that? I suppose I do. Why not, huh? Let's go ahead and do that. We will say, okay, so x times the negative 4, so that's 4x. And we'll also say x times, you see that negative is going to make both of them negative, so we're going to say square root of 6 times x also. And then we'll do it for the other one. We'll say this times the x, so I'm going to get the same exact thing. I'm going to get negative 4x, and I'm going to get, well, it won't be the same thing, will it? Because now this is going to be a positive. So I get positive square root of 6x. Okay. And then finally, at the very end, I'm going to say these two guys together. Maybe I'll do that in red. This one, well, I was doing it in green. I'll stay with green. If this one times that one, in other words, times itself. So I'm going to say, I'll probably have to do that off to the side. I'm going to say, let me just write it next to each other. They're both negative, so I'm just going to write it as positive, because I know they're going to be like this. Okay, and you agree, negative times negative is a positive, so I'm going to dispense with that negative. These are conjugates of each other, so I don't expect a middle term. So I get 16, and I get minus 6. 4 times 4 is 16. Square root of 6 times square root of 6 is 6, so 6 take away 6. One of them is negative, so it's negative. So that's 10, so I'm going to say plus 10 when I get done here. After all that, it was just plus 10. Okay, so I have x squared minus 8x. These guys cancel, and plus 10. Okay, so I have x squared minus 8x plus 10. Okay, so let's go ahead here. Let's multiply these out together. we'll say this times this and this, and I'll say x to the third plus 4x. And then I will say negative 2. I didn't leave a space for x squared, so I guess I got to put it over here. Negative x squared. Pardon me. Negative 2 times 4, that's negative 8. So I'll write this in the right order, and I'll say x to the third. Let me put the negative 2x squared before I put the positive 4x minus 8. Alright. Yours won't be this bad because yours isn't going to be 5 factors. But this is kind of bad. Oh, I said plus and I meant negative. This is a lot of work. You can see how, as long as we just keep our wits about us, we can do it. I'm going to say this times this, and then times this, and then times this. Okay? So let's see. X to the third times x squared is x to the fifth. X to the third times minus 8x is minus 8x to the fourth. X to the third times 10 is 10x to the third. Then I will go ahead and do this one times each one of these. Okay? And negative 2x squared times 2x squared is negative 4x squared. Wait a minute, there's no other 2 there, sorry. No other 2. So it's just negative 2x to the fourth. I got 4 on the brain. 2 times 8, they're both negative, so positive 16 x to the third. Negative 2 times 10 is negative 20 x squared. Let's see, we'll go with 4x times each one of these. And we get 4x times x squared is 4x to the third. Notice that I line it up with x to the third. 4 times negative 8x, 4x is what I meant to say, is negative 32x squared. 4x times 10 is 40x. And finally, we get negative 8 times each one of these. Negative 8 times x squared is negative 8x squared. Negative 8 times negative 8 is 64, and x comes along. Negative 8 times positive 10 is not a positive. It's a negative 80. My oh my. Well, here we go. We have a leading coefficient of 1 like they asked for. X to the fifth minus 10x to the fourth plus 16 and 4 is 20 plus 10 is 30. X to the third. We have negative 8 and negative 32 is negative 40 plus negative 20 is negative 60. X squared. 40 and 64 is 104. X minus 80. All right, that is a polynomial with 5 roots. Okay, we know what the roots are. The roots are there's 2 imaginary roots. Okay, and there's 2 irrational real roots and 1 real rational root. Okay, why do I say irrational? Because the square root of 6 is irrational, so if I take that away from 4, that means it's irrational. But they're real. There's 2 real roots here, irrational, and then here's 1 real root, real, and then here's 2 imaginary. So altogether we have 5 roots, right? And that's our answer. That's our polynomial they asked for. Write a polynomial function. Yeah, I just did that. Of least degree. Okay, it was x to the fifth. I had to say x to the fifth. That has rational coefficients. I look back, you know, if one of my coefficients was like the square root of 2x squared, that would be no good, because that's not a rational coefficient. But all my coefficients are rational. And it has a leading coefficient of 1. Yay. Okay, that's real helpful. That's nice. And the given zeros. Wow, what a problem.